Okay. All right. Let's get started. All right. Data summaries. The first data summary we're going to look at is a tally table. Now, I'm sure you guys remember this from grade 8 math. They did it in grade 8 before, but if not, if you don't remember, it's fine. We're going to remind you again. So here we have a data set, okay? And there were two questionnaires that were put forward to people. The topic doesn't really matter, but we've got some data from the data sets in these two questionnaire answers here. So the first row is from the first questionnaire, and the second row is from the second questionnaire. And obviously, the type of question, you guys will be able to tell me, but it's obvious it's a yes/no question. So it's just two options, either yes or no, that were answered in this questionnaire. Okay, now we're going to learn how to put this data from this questionnaire in these two rows here into a tally table. And then from there, we're going to learn how to transfer it to a frequency table and take it a bit further from there. Okay, so I'm going to do the first one. Now, I can't see you guys, and it's hard to put a tally online. So I can't see you guys do this, but when I say so, I'm going to ask you to draw your own one, not these two. I'll do the first two for you. But when I ask you guys to, I want you to draw up a little table and do something similar. So just watch how I do it. Now, the cool thing about a tally table is it's a visual representation. All right. So when we look at these two questionnaires here with the two rows, questionnaire 1 and questionnaire 2, we can't really see how many said yes and how many said no. We can get an idea of how many in each questionnaire, but we can't really tell just by looking at it, a quick glance, how many yes and how many no, who was more yes or no. All right. So a tally table helps us with that. And it's a quick, easy way to count up all the values in the data set. All right. So I'm going to start with questionnaire 1. I'm going to show you guys. I'm sure you've done it before, but here goes. All right, so for the first questionnaire, I'm going to write here first. This is the first questionnaire. We're going to count the yeses first. All right, so we're going to say yes, and I cross it off after I've counted it. This way, it's easier to see that you've counted that value, and also it'll leave all the ones you haven't counted left over. All right, so 1, 2, 3, 4, 5. Okay, so 1, 2, whoopsie. 1, 2, 3, 4. So you draw 4 vertical lines like that. And then for the fifth one, you cross diagonally through them all. Okay. So you should see 4 vertical lines and 1 diagonal that crosses through them all. All right. And we counted 5 yeses and we have 5 lines marked here. So we have done tallying up the yeses. And now we're going to do the no's. I'm going to cross out the no's as I count them. So 1, 2, 3, 4. All right, so I've counted all the values of my data set. Now I need to mark it down here on the tally. So 1, 2, 3, 4. Okay, so that's what it should look like for the first questionnaire. And then I'm going to do it for the second questionnaire. And I'm going to count the yeses first again. So 1, 2, 3, 4, 5, 6, 7 yeses. And let's mark the tally down. So 1, 2, 3, 4. Every fifth one is a diagonal line. And then we start again. 1, 2. Okay. Now we're going to count the no's. 1, 2. And then put 2 marks down in the no row. Okay, so that's how we do a tally. So it's 1, 2, 3, 4, and then the fifth one goes diagonally, and you start again 1, 2, 3, 4, and then the fifth one goes diagonally 1, 2, 3, 4, and the fifth one. So if we look at this example here that I've got on the right hand side, we can quickly see that we've got 3 groups of 5, so 5, 10, and 15. So that way we get a good idea or a quick observation of how many yeses and nos are in each questionnaire. All right. Now, if I look at my tally table, it's also very easy to see which answer was answered the most, the yeses or the nos. We can see in the first questionnaire over here that the yeses were most, and in the second questionnaire, oopsie, we can see again that the yeses were most. Let's scroll down quickly. All right, there we go. Okay, so we can see again that the yeses were most. All right. So a tally table is just a very quick way to count. And then once you've got the marks down, the markings, you can quickly glance at it and see exactly how many there are. All right. So it's just a quick way to count up and put marks down to have an observation of how many there are in the data set. Okay. Let's carry on and take this a little bit further now. All right. Now, I've got a heading here. You can see it at the bottom. We're going to move on to a frequency table. And in words and brackets here, say discrete data. Can anybody tell me, raise your hand and unmute so you can let us know. Can you give me an example of discrete data? What is discrete data? Can you explain what you understand is discrete data? Emmanuel.
Yes, discrete data is the data that does not change. Or rather, if it changes by the same value.
Okay, in a way, yes, it doesn't change if it changes by the same value. Okay, so for example, if you have 1, it can become a 2. All right, yes, good. Let's see who else raised their hand there. Good, thank you, Emmanuel. Just having a look to see. Okay, so Kile, just check there. You should be able to unmute. Yes.
Hi, sir.
Hi, how are you?
Good and you, sir.
Good, thank you. What do you understand is discrete data?
It's data consisting of numbers that have individual values, and it consists of whole numbers and no fractions.
Good, whole numbers, very good. That's the word I was looking for. So whole numbers. Okay, so you got to be careful because whole numbers also have 0. We could have a value of 0. That's fine. Whole numbers or integers. We can actually have minuses in our data set as well. For example, this could be a data set -3, -2, -1, 0, 1, and 2. Okay. Discrete data are these values here at the end. All right. 1s and 2s. For example, if you're counting cows, remember I used the analogy of cows. If you're counting how many cows, you're going to get whole numbers, usually people as well. Remember we used questions on Tuesday, for example, how many days did you work this week? And we used whole days, so 3 days a week or 4 days a week. So it's whole numbers here with, like Sakila said, with no fractions or decimals. Okay, so whole numbers with no fractions or decimals. All right, so that's discrete data. Okay, so here we go. Here is another set of data, and you guys are going to do this one, but I've added another column in. You can see here, instead of just the tally column, I've added the frequency column in. All right. Who can tell me what is, very good, Brenda, countable? Yes. Who can tell me what the frequency column is going to tell us? What does the word frequency even mean? Frequency. What is this word frequency suggesting that we put into this column here? Anyone? You can type in chat, or we'd love to hear your voices. How many times it appears? Thank you, Sonia. Very good. All right. So how many times it appears? How many of that value? Okay. So how often and how many? Good. Very good. Thank you very much. How often and how many? Yes. Very good, guys. Good answers. So, for example, now this is not according to this data set. For example, if I had a tally of 1, 2, 3, 4, 5, 6, 7, then the frequency would be 7. Okay. Now, you guys can draw up a very quick tally table, include the frequency column, just put headings, just write there tally, say yes, no, draw a line across, draw a line down, down, and then write frequency. You can write that in your books, okay? And then I want you to complete this frequency table for this data set that I have over here. It's not 2 questionnaires, it's just 1 questionnaire that's given us all these values over here. All right, so I want you guys to draw up a tally table so you can see how to do it. And then you're going to tell me what the frequency values for the yeses and the nos were. Okay, I'm going to give you about 2 minutes to do that. Shouldn't take you long. No problem, Levifane. So frequency, if we have a tally, for example, if I have like 7 sticks here, okay, the frequency is saying how many of those marks or sticks do I have in my tally. So instead of trying to count the sticks, the frequency column is going to show an actual number. All right, so it's 7 of the yeses, okay, and then you might count 3 no's, and then in the frequency column you're going to have 3 no's, 3 of the no's, and then in your total column here you must add up your frequencies. All right, but you're going to do this yourself with this data set that you see on the screen here. I've got a whole lot of yeses and no's. You're going to do a tally for them first, and then put the frequency number in for each one, and then do a total. All right, should we almost done now? Nice, quick, easy little task. Shouldn't take you long. All right, there we go. Answers are coming in thick and fast. It's hard to display your values in chat. I know, that's why I suggested maybe drawing up your own little table, and then we'll compare the answers, me and you, when you look at your table and you look at mine. All right, you guys should be about done now. So let me work through this one and you compare yours with mine. I'm going to count the yeses first. You keep putting answers in, that's fine. So 1, 2, 3, 4, 5, 6, 7, 8, 9 yeses. I'm going to say 1, 2, 3, 4, 5, 6, 7, 8, 9, and the frequency is 9. Then I'm going to do the no's. 1, 2, 3, 4, 5, 6, 7, 8. So 1, 2, 3, 4, 5, 6, 7, 8. Put there 8, and the total, like you all put in the chat there, is 17. All right, so we got 9 for the yeses, 8 for the no's, and a 17 in total. Very good. Well done. Good job. Good job. Yes, fantastic. Okay, so I'm sure if you had done this yourself, this table, and put in the markings yourself, you would have realized, why must I do a tally if I can just write the number down? Well, this is why we moved from doing tallies to a frequency column like this. But sometimes if you want to just get a quick idea, especially when you're counting a lot of numbers, if someone's calling them out to you or something like that, it's very quick to do a tally. Helps to make sure you don't make any mistakes. Okay, so a tally does help. It caters for every single value and tries to rule out any human error. So sometimes it is quite useful. Okay, so now that we have these values here in our frequency table, an important thing to do is to make sure that this total here at the bottom matches how many values you have in your data set. All right, so what you should always do, especially if you have time, I'm not saying that you should spend the time on this in the exam. I'm saying if you have time, make sure that you count all the values. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. All right, so I counted my data set. It matches up with my total, my frequency table. So that is correct. Okay, so it's always good to check that your total is correct. All right. So we looked at discrete and continuous data on Tuesday. If you want to have a look at the video, you can check Watobe's YouTube channel, but we had a diagram like this and we were explaining it. Basically, discrete data is when you count with whole numbers, and continuous data is when you measure and you get decimals. All right, so it's a numerical value, can either be discrete or continuous. Discrete is counting with whole numbers, and continuous is measuring with decimals. But go have a look at Watobe's YouTube channel if you're not sure, if you want to get more information about it. But we did that on Tuesday. All right, so go have a look at Watobe's YouTube channel. Go check in the video there. You can see exactly where we explain discrete and continuous. In fact, go and get the whole lesson if you didn't catch it. We covered quite a bit there in that lesson, quite a bit of theory. Okay, so I would go and look at that whole lesson again, in fact. Now, here's it comes a question on the frequency table. Very easy question. What percentage answered no? Now, usually when you get these questions, they say calculate a percentage of a certain value, right? And I always told you that the of goes at the bottom of the percentage fraction, okay? So the of value is obviously of the total. All right, that's why we need the total here. So what percentage of the total answered no? Should be a quick calculation for you guys. Sure, Sonia. Incredible speed.
Can I speak, sir?
Yeah, sure.
I want to know the calculation will be 17 over 100 or 17 over 10.
Okay, so good question. In your percentage fraction, when you're saying 17 over the of, all right, so in fact, let me change the question. So I've shortened it a bit here, but this is what it should usually be. So what percentage of the total answered no? All right. So when you see the word here of here, and then what comes after it of the total, that value that comes after the of word must be at the bottom of the fraction. So you must have 17 at the bottom of the fraction. Okay.
Yes, sir.
So we're working out a percentage of that number. And what do we want to try to find? How many that answered no? So that must come at the top. So it'll be 8 at the top out of 17. And then multiply by 100.
Oh, okay. Thank you, sir.
Pleasure. Okay, so 8 over 17 multiplied by 100. Let's do the calculation here on my calculator so you can see it. Okay. Ooh, we get a long decimal number here. Okay, I'm going to write the whole thing out. So 47,058823. 47,058823. 47,058823%. Now, as you all know, the instruction on the exam will always say round off to the second decimal place. So this long decimal here, we're looking at the second decimal, which is the 5. Will the 8 that's next to it change it up, or would it leave it the same? It's an 8, it's above 5, so it will change it. So that will become 47.06%. All right, so 47.06% of the people in this survey answered no. All right, so once we have these frequency values, let me just check. Yes, you guys. So you guys rounded off to 1 decimal place there. All right. A lot of you rounding off to 1 decimal place. So you change the 0 to a 1. All right, just remember that you're always trying to round off to 2. So don't forget to show the second decimal. All right. Unless my answer on my calculator is different to yours, but I think it should be the same. Let me quickly check it again. 8 over 17. Yeah, all right. So the second decimal is a 5. We want to show the second decimal, and it's going to change to a 6. So try and make sure that you're rounding that second decimal off. Okay. Unless they tell you otherwise. So the instruction in the matric exam, which is the one we're always going to refer to, is round off to 2 decimal places unless otherwise stated. In other words, do it always unless we tell you to do something else. Okay. All right. Let's move on to another frequency table. Okay. But this is going to be continuous. Why do we say 8 over 17? Where does the 8 come from? All right, good question. All right, let me just go over it again. Nicholas, have a look here. So they say in the question, what percentage, all right, I'm going to erase all of this for a second and then bring it all back. They say here in the question, what percentage of the total answered no? All right. So we're going to work out a percentage, which is what you see on the screen here, this calculation. What percentage of the total answered no? All right. So they want to know of the total, which is 17. That's what we're going to work out a percentage of. So that's going to come underneath the bottom of our fraction. Answered no. So the no value from the frequency table is 8. So that's why I've got 8 in my percentage calculation fraction over here. Okay, and then I just times by 100 to get a percentage. Okay, I hope that helps you. I saw someone raise their hand there. Malefane, you have a question?
So sorry, you already explained what I wanted to ask.
All right, no problem. Excellent, no problem. Glad we got it. Okay. All right, let's move on to the frequency table for continuous data. Now, who can remind me what is continuous data? What type of data will be continuous data? Anybody? We spoke about discrete and we learned about discrete. It's like counting cars or counting cows. Then what is continuous data? What's an example of continuous data? I wonder if you was here on Tuesday remembered what I kept on referring to for continuous data. One that is measured when the numbers have decimal. All right, excellent. Very good. Those are the two things that I wanted to hear. Very good. So these are numbers when we usually measure. Petrol prices, very good, Emmanuel. That's a good example. Petrol prices, because you have rands and cents, which are decimals. So these are numbers that we can measure. When you're pouring petrol into the car, you see the counter ticking over, and it increases and increases and increases. All right, like 4 Rand 25, 4 Rand 26, and it just shoots up, extremely fast because the petrol cost is so expensive. Length of grounds or oceans. Good, Tian. Yes, that's an example. If you want to measure the length of a ground, like a sports field, or like a water body, how long is this dam, or how long is it from one side of the ocean to the other? That's distance. Very good. You can measure that. That's continuous data. So it's and you can measure it. All right, and you get decimals. That is continuous data. Weight. Very good. Bills. If it's in rands and cents all the way to, yes, bills will be continuous data. Good. Okay, so if there are decimals and it can be measured, yes, that is continuous data. You guys are on the ball. Okay. Now, a frequency table with continuous data looks a little bit different for a very good reason. I'll explain this when we see it now. Okay, here's the data that we're talking about. There's quite a bit here. So we're going to have to be very careful when we analyze this and put it into our table because there's quite a lot. Yes, Whatever distance can be measured like with a ruler. Lucky Hugo will have a look at that. He'll try and change your name quickly. So yes, distance can be measured with a ruler. Measure a distance. Let's say you're doing long jump at athletics. You can measure it with a ruler, or you measure your height, all right, or measure how far you threw a spear or a javelin or a hammer. You can measure that distance. You can get maybe 8,25 meters. That is continuous data. Okay. Height will be, because that is a measurement that you can measure. And you can get decimals. Like my height is maybe 1.65 meters. I think I'm taller than that. I'd like to think I'm taller than that. But if I can measure my height and I get decimals as an answer, that is continuous data. Distance, yes. Very good. That is continuous data. So here we have the height of female learners in a class. Okay. On Tuesday, we spoke about the heights of rugby players. Now we're talking about the heights of female learners in a class. And these are all the heights here. And you can see these heights have been measured in meters. The units are in meters. And every single number except for this one here in the middle at the top, 1.4, has 2 decimals. This number at the top only has 1 decimal, but there are decimals. All right. So this definitely is continuous data. Okay. Now, you've got to be careful with putting this data into a frequency table, because in the previous question, we only had 2 options. We had yes or no. Now, in this data set, we could actually have an unending amount of options here. We can start from 0 meters and go up to, okay, we've got to be realistic. Maybe there aren't girls that could be 2 meters high, but you could have 1.43, 1.44, 1.45, 1.46. I mean, it's never ending. Okay, so we could have, we can't actually draw up a table and say, all right, what about if we start at 1 meter? How many were there at 1 meter? How many were there at 1,01? How many were there at 1,02? How many were there at 1,0? I mean, we'd be writing values all day, wouldn't we? And you hardly will fill these values. You might find, there's one person at 1,02, and then miss a whole lot, and then find another person. So surface area is, yes, absolutely. So it's hard to build a frequency table with continuous data, because there's so many possibilities and we can't list them all. It'll take forever. So there's a way that we do this. All right. So what we do is we group, okay? We group the data. So we say, we're going to say a group of data. So if I look at my data here, I've got values down to 1.11 over here. So that's a very low value. So I could start at 1,10 meters and be safe. I'm sure I'd catch them all if I started at 1,1. And then my highest value, 1.57, 1.57. I think my highest value is 1.57. So I've got to go from 1,1 and make sure I catch the 1,57. So if I went to 1,60, between 1,1 and 1,60, I've caught everyone in that data set. Okay. So what I need to do now is make groups, okay, between 1,10 and 1,60. So what you can do is you can say, well, I want to group all the people that were 1,10 to 1,19 in one group. Then in another group, I'm going to say 1,20 is the next value, and go up to 1,29. That'll catch some there. And then I'm going to make another group, 1,30 to 1,39 will be in that group. And anyone that's 1,40 to 1,49, and I'm going to have to make another group here. So I'm going to erase the 1,60. I'm going to make 1,50 all the way up to 1,59. Okay, so what I've done is I've started at my lowest, making sure that I catch it in that group. I check my highest, I've caught it in this last group here, and then I group everyone else in a similar group. So I've got 5 groups here, 5 intervals, okay? It's often called interval data or grouped data. I've got 5 groups, and all the people in my data set are going to fall in one of those groups. Okay, I hope you understand what I'm trying to do here. So instead of writing all the numbers from 1,10 all the way up to 1,59, I've grouped the heights over here. Okay. Yes, Bianca.
Hi, sir.
How are you?
I actually don't understand where does those values come from. 1,10 till
Okay.
those numbers.
Okay. All right. I'll explain again. Not a problem. So what I did here to create these groups here, I looked at my data set and I said, what is the smallest group? Because if you're looking at heights, height can go all the way from 0 meters. It can go up forever, So I'm trying to minimize writing down every single possible height in my table. to try and show every height. So I'm not going to start at 0 because my smallest value in my data set is 1,11. Okay. And then I had a quick
Okay.
look and I found that the biggest value in my data set is 1,57. Okay. So what I could do, Bianca, is I could start at 1,11 and let me move over a little bit here. All right, so what I could do is if I wanted to, I could draw a frequency table that started at 1,11, then said 1,12, then said 1,13, and list all the possibilities up to 1,57. I mean, it would take a long time, but I could list them all like this in a table, all right? And that could be my one column. And then the next column would be my frequency column. In other words, how many are there in that that have that height? And then I would look at my data and say, I've got one person that's 1,11. And then I would miss a whole lot, all these values I'd miss. And then at the end, I say, I've got one person in 1,57. So instead of having a long list of all the possible heights listed, you group the heights into groups. Okay. So I'm going to group the first 9 heights into a group and then say how many of these learners are in that group. So I'm not saying how many learners are of each height. I'm saying how many learners are in a group from 1,10 meters to 1,19 meters. Okay. Does that make a little bit more sense?
Yes, sir. Thank you.
Okay. So watch now when I start putting the values in, it'll make a lot more sense. Okay. So now in my frequency table, all right, I'm going to start counting. So far, if I look at my data set, I've got one person that is in the group from 1,1 to 1,19. Here's 1,11. Are there any more? You see there's someone actually below that. So actually my table needs to be lower. I even missed that. So let's go from 1,00 to 1,09. All right, so let's put F for frequency there. I can find there's one person in 1,05. Okay, so far I've got one person in 1,05. Then I can say, there's one person in the next group over here. So I'm actually going to start doing this in fact, I'll start doing it here now, and then I'll let you guys finish it off. Or you can help me finish this off, all right? So I've got a frequency table at the bottom here that's already set up, and I'm going to do a tally and a frequency column here. Okay, so let's use mine that I've built already. You guys must help me here because there's a lot of information. There's room for human error whenever there's a lot of numbers. So you're going to help me out here. So what I'm going to do is I want to count how many do I have in the first interval here in my table that goes from 1.0 to 1,09. How many do I have? Well, I'm going to say that is 1. And I don't see any more. So I'm going to put 1 in my tally and put a 1 in frequency. Now I'm going to count from 1.1 meter to 1.9 meters. How many do I have? Well, there's 1 there. And here's another one, 1,14. I've got 2. I can only see 2. So I'm going to put 2 there and 2 in my frequency column. I've got 2 in that group. Okay. Now from 1.2 meters to 1.29 meters, how many do I have? Well, there's a 1.22. Here's a 1.23. I'm looking. I don't see any more. So I've only got 2 that fall in that group. Okay. Let's do the 1.3s. All right. 131, that's 1. 138 is 2. 137 is 3. 132 is 4. I've got 4. As far as I can see, I've got 4. Now I'm going to do the 1.4s. 1.43, 1.49, that's 2. 1.4, that's 3. 1.44 is 4. 1.44 is 5. 1.45 is 6. 1.48 is 7. 1, 2, 3, 4, 5, 6, 7. Put a 7 there. Now I just need to do the 1.5s. I've got a 1.57. Oops, I've missed a 1.49. See, human error comes in 8. So I've got 1.57 there, another 1.57, and a 152. So that's 3. Okay. Now we're going to do the total. So 1, 2, and 2 is 5, and 4 is 9, and 8 is 17, and 3 is 20. Okay. Now I'm going to go back to my data set like I checked. 1, 2, 3, 4, 5, and I've got 4 rows. 1, 2, 3, 4. 5 times 4 is 20. So I've done it correct. Okay, it's always good to check. Very good. Thank you. Yes, thanks for your help. Thank you for your help. You guys also add up fast. Okay, so this is a way to show continuous data. Continuous data is often shown in a frequency table like this. They don't list every single possible height that you can get because it could be endless. They only put it into groups. Okay, and then you've got to put those numbers into those groups. Count how many numbers are in each group. The group from 1 meter to 1,09. The group from 110 to 1,19. Okay, I hope you guys understand that. Okay, I hope that makes sense to you. All right. Now, I know what you're thinking, Teacher Dale, are they really going to give us this in the test? I don't think, I mean, this came from a test, but I don't think they will give you 20 numbers like this. Maybe a few, you know, but they will draw the table up for you. So you won't have to worry about which groups must I make. They will draw up the table for you. So this part will be given to you for sure. Maybe not a tally column, but definitely a frequency column. Okay, maybe a tally column. But the heights and the groupings of the heights, excuse me, that will always be given to you. Okay, that'll be given to you. So you don't have to worry about making those groups. They'll do that for you. But as you can see, it's easy. You just start with the 1.0s to 1.09s, count them off, put a tally, put a frequency. All right. Now, once we've summarized our data, because this is all about summarizing our data, this is where the fun part comes in, because now we can do analysis on this. Now we can question this. Right. Now we can ask this questions. So we went from a block of numbers. We went from a block of numbers in the beginning. There they are, to a table representing their frequency, and now we can ask a whole lot of questions. So here come the questions. This is where you guys come in. This instruction at the top, draw up a frequency table that you can use to organize the following data gathered about the heights of female learners. I've made a mistake. It's not male, it's female. My apologies to the ladies. So how many female learners were in the study? It's easy to see. Now that we have a frequency column and a total, it's easy to see. We might have had to count it in the beginning, but now in the frequency table, it's easy. We just say, oh, it's 20. Okay, so how many female learners in the study? That's easy. It's in my table. Yes. Yes. Yeah, we can read it out of the table. It's so easy to do now. All right, here comes the next question. How many learners are there in the interval from 1.3 to 1.39? How many learners are in the interval from 1.3 to 1.39? There we go. Nice and easy. Answers are coming in thick and fast. Good. Nice and easy. Very good. All right, 4. Easy to see because we've got a table now. If we didn't have this table, we'd have to go into the data set, guys. We'd have to go to all these numbers in the data set and try and sift through and find all those values. But with a frequency table like this, it's all there for us to see. Okay, so easy to see. All right, well done. 4 learners. Next question. How many learners had a height of below 1,2? A height below 1,2. Below 1,2. How many learners were there with a height below 1,2 meters? Ah, some interesting answers coming out here. Okay. So where is 1,2? Here is 1,2. Okay. We don't want 1,2. We want the values below that. So that is all of this. All right. If 1,2 is there, these are all the heights that are below 1,2. How many are there in those heights, which is all below 1,2? Well, we've got 2 in that row, and we've got 1 in that row, so that makes a total of 3. Yes. 3. Excellent. All right. Three learners. And it's easy to read because we've got this table now. All right, next question. What percentage, so we're going to do a percentage calculation, of learners had a height of 1,4 meters or above? What percentage? I'm going to bring this question up. Here's the question up here. What percentage of learners had a height of 1,4 meters or above? What percentage have a height? What percentage of learners have a height of 1,4 meters or above? Sure, Bianca, that's fast. That is very fast. You guys do it. We're going to check it. All right. Don't worry about answers popping up in chat. You do it yourself. Don't worry about everyone else's answers. You do it yourself. You do it yourself. Don't worry about everyone else. You do it yourself, and we're going to check your answer in a minute. Interesting, Abigail. Make sure you guys do it yourself. Hey, don't worry about what's happening in chat. You do it yourself, and you check the answer once we've done it on the screen. Okay. All right. Looks like you guys should be done. Okay. Let's have a look. It's a percentage calculation, so we need a fraction. And it says what percentage of the learners, so the learners, the total value is coming at the bottom. What percentage of total learners had a height of 1,4 or above? All right. So here's 1,4 over here. We need 1,4 and everything above. So we need everything in this row. Whoopsie, let me highlight it. We need everything in this row. And we need everything in this row. All right, because that's 1.4 and to 1.49 and 1.5 to 1.59. So that is 1.4 and above. There are a total of 11. 8 plus 3 is 11. That are 1.4 and above. And we need a percentage, so we've got to times this by 100. Okay, I've got my fraction here. I'm just going to change the values. I need 11 at the top. And I need all my learners at the bottom, which is 20. Ah, not even any decimals. Nice and easy. All right. 55%. Okay. I hope you guys saw how we did that. The percentage of the total learners that are 1.4 or higher. Okay. So it's the last two rows, which had 8 and 3, which becomes 11. So it's 11 over 20 times 100, which is 55%. All right. So I hope you guys are seeing how useful a frequency table can be, especially for continuous data, for data with decimals. All right, we have to group the values into groups, but it can be very, very useful, and then we can ask a lot of questions here if we have this frequency table in front of us. And this is the cool thing about data. If you know how to summarize it and analyze it, you can tell a lot of information about data. When we first saw this block, all right, when we first saw this block here, we couldn't really tell anything. But once we summarize it in this table, then we can start interrogating it and analyzing it, asking a whole lot of questions. Now we know a lot more about what's going on in this class. Okay, so more than half of the people in this class are higher than 1.4. Very interesting.